Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us solve the next question, number 32 of NEET Physics paper 2015. Students, let us solve the question number 32. It says block A of mass M1 rests on horizontal table. This is a block of mass M1 resting on a horizontal table. A light string connected to it passes over a frictionless pulley at the edge of the table. So there is a string and there is a pulley over here. Through this pulley, the mass over a pulley, and from its other end another block of mass M2. So this is having mass M2. This block is A and this block is B, having masses M1 and M2, and the situation is like this, that the string passes over the pulley and connected to the another block of mass M2 is suspended. The coefficient of kinetic friction between the block and the table, here the coefficient of kinetic friction, that is mu sub k is the coefficient of kinetic friction. When the block A is sliding, if this block sliding on the table, the tension in the string is, so if this slides, it is because of the tension T, and if this slides, this also has to slide down, so there is a tension acting in the upward direction, and this block is having its gravitational pull downward, that is M2G. So if this is this has to slide, this has to go down. Suppose that the acceleration of this block is A and acceleration of this block is A, because they are connected. Because they are connected, they have a common acceleration. Okay, because the string is inextensible, and therefore for the string to be taut, the acceleration of both the blocks will be same. If this moves by acceleration A, this has to move by acceleration A, because this is constant motion. When the block A is sliding on the table, the tension in the string is, so what you have to find is this tension is how much. What is the tension in the string? The tension here and here are the same, one string, one tension. So you have to find the value of this tension, and these are the four options given, and we have to find which one is correct. To solve this, let us first write the force equations for both the masses. For this mass M2, the force equation will be M2G minus T is M2A. This is equation 1. This is from Newton's laws of motion. For the block of mass M1, which is this block, the equation we can write as that this tension, and there will be one force, frictional force, that will act in the opposite direction of the motion of this, and that is mu k into n. This is the frictional force that will act. And what is n? The n, because this is having a gravitational pull of mass m1g, and this is having a normal reaction n. So this n and m1g are equal. So therefore, in place of n, I can put mu k m1g. These two are same. So the equation will be this force minus this force, that is the resultant force, will produce mass m1 into acceleration a. So I'll write T minus mu k m1g is m1a. This is the equation number 2. Now these two equations have two unknowns. One is T, another is A, and we are supposed to find T. To find T, first let us eliminate T, find the value of A from here. Once you get the value of A from here, you substitute any one of the equations. So that will get the value of t. So if I add these two equations, this will cancel. If you add these two equations, this will cancel, and here it will be m2g minus mu k m1g is equal to sum of these two, that is a common m1 plus m2. So a is common, so if I want to find a will be this value divided by m1 plus m2. So then a can be written as this value, that means if I take common g, it is m2 minus mu k m1, okay, divided by m1 plus m2. This is the value of a. Now we can take any one of the two equations to get the value of t. Now if I take equation 1, then this t becomes this minus this. So from equation 1 we can write t is m2g minus m2a. You can see here t goes to that side, this goes to that side, so m2g minus m2a. Now, so from here I write t equals to m2g, this is okay, minus m2a. In place of a, I will substitute this value, which is g m2 minus mu k m1 divided by m1 plus m2. So now after this you have to see the options in which form you have to express. See, in all the options m1 plus m2 is there in the down, so you have to write the expression in terms of this, that you have to take this as common. So to take this common, I will take the LCM on both the terms, so it will become m1 plus m2 down, and this m1 plus m2 will be multiplied here, so it will become m2g multiplied by m1 plus m2 minus this value m2g minus into m2 minus mu k m1. Okay, this is the tensor. Now to solve it, to get any one of the following answers. So t equals to, I have to solve this, I have to multiply this, because here you can see one thing is that all the options in the numerator, g is common. Okay, g is common. So I'll try to write g common, because m1 plus m2 in the denominator I've already got. So g I have to take common. So from these two terms, this is one term, this is another term. So g I will take common. Then I will multiply this and open the bracket. This g being common, multiplied m2 with m1 plus m2 first. So this will become, so g common, down it is m1 plus m2. Okay, now what will be what is left? It is m2 is multiplied with m1 plus m2, so it will be m1 m2 plus m2 square. Okay, this will be m1 m2, this will be m2 square. Similarly, minus g is there, this is gone out, m2 square minus, if this goes inside and I remove the sign, this will become minus m2 square plus of m2 m1 mu k. So minus m2 square plus of mu k m1 m2. Okay, you can see here that if I multiply, g is not there, this will be m2 square, and this minus minus becomes plus, and this m1 m2 is m1 m2 into mu k. So from here I can write that this will cancel out, and from here I can write m1 m2 also common from these two equations. So this is m1 m2 being common out, and g is also there, this is m1 plus m2 down. Inside we'll have 1 plus mu k. So finally I am getting this expression, and I have to see which of this is correct. If I see this, then this is the correct option. I'm getting m1 m2 g outside 1 plus mu k. m1 m2 g outside 1 plus m2. So this is the right answer to this question. Okay, thank you.